Graphing polynomials. We will graph polynomials when we cannot factor the polynomials. We will use the rational root theorem with synthetic division. So let's talk about how to graph polynomials. So one, remember we determine the end behavior. We find all zeros of the function. And to do that, you can try to factor or synthetic divide. Then you find the y-intercept, and then you can pick and choose x values between the zeros to graph. Or in this case, we're just going to sketch the graph. We're not going to really do number 4, but if you want a more accurate graph, it would be nice to find several x's and then get a more accurate graph. So you plug in, 3 for x, what's the outcome? So before we move on, I want to talk about the rational root theorem. It says for any polynomial, we can find the rational roots by, so the possible x's, you will take the factors of the constant divided by factors of the leading coefficient. Then what you're going to do is pick and choose from that list. So before we find the possible x's, the number of possible x's is infinite. We can pick whatever we want, but that will it's kind of redundant to do because you may pick numbers that aren't really that would not really go into that polynomial. Now, granted, there are some of these possible x's are not the actual x's, but at least you have a nice handful to choose from. So then what we're going to do is find the possible x's. If we cannot factor, we're going to find the possible x's, use synthetic division, and figure out our zeros. And remember the zeros and their multiplicity, if the answers repeat an even number of times, it bounces off the graph. That was from the last video. So let's graph the poly function, the polynomial function. Okay, so for this one, if you look at this, we cannot factor it. We cannot group the first two and last two and factor it. We would get different values in the parentheses. So we still will need to graph this. Find the possible x's. So the possible x's, we are going to take the factors of 3, which is plus and minus 1, and plus and minus 3, all over the possible, or the factors of the leading coefficient. So 1 and 3 divided by 1, that's positive and negative 1, positive and negative 3. The 2 we have positive and negative 1/2 and positive and negative 3/2. So we have 8 values we can choose from. I will choose one factor that I know will not work so you can see this process. So we will take our polynomial and set it up in our synthetic division. Bring down the 2. I'm going to use a pencil so I can erase. Let's choose negative 1. So 2 times negative 1 is negative 2. Add, multiply, add, multiply, add. We get a 12. We get a remainder. We don't need this. That means that the negative 1 does not divide into this polynomial evenly. So that means if you plug negative 1 in for x, you will not get a 0. You will get a different value for your y, which that would be what, 5, no, that wouldn't be 5, be 1, 9, 10, 11, 12, 13, that would be a 13. So at negative 1, we'd be going up to 13. Okay, so with that, if you plug in negative 1, then you will not get a 0. So I always put a used spot, which would be my negative 1 here. So negative 1 doesn't work. Let's go ahead and I'll show you how to do a half. Okay, half of 2 is 1. 3 plus 1 is 4. Half of 4 is 2. What, negative 6. Half of negative 6 is negative 3, and we get 0. So we know that there is a x, or the graph crosses at 1/2, 0, or on the x-axis at 1/2. Now, to keep working with this, we can take our new polynomial and factor it, since it's now something we can work with easier. So sometimes synthetic division helps you get to something that is factorable. Okay, the 2, I can divide that off, so we get positive 3 and negative 1. So when we solve for both of those, we get a positive 1 and a negative 3. So we know our x's. We need to find the end behavior, so the left and the right. The right's going to go up, the left's going to go down. We have a positive leading term, so the right's going up. We have an odd power, so the left's going to go down. And then, our y-intercept is 3, so plug 0 in for x, and you get, actually, you just get the constant, because you plug 0 in for x, so 0, 0, 0 plus 3 is 3. Okay, so after we get all of that done, we can now graph. So we can plug 3 on our y-axis. Oh, positive 3. I don't know why I was thinking negative 3. And then we can plug our x's in at a half, at 1. So yeah, sometimes it gets really close. And negative 3. 1, 2, 3. Okay, so just as before, we're going to take our rightmost point and we're going to go up with it, and our leftmost point we're going to go down. So then we're going to just sketch it. So a loop here, going up here and down. And that's just a sketch. So when we said negative 1, when you plug negative 1 in for this function, we said it was going to be all the way up to 13. So this actually technically needs to go way up here. But we're just sketching the graph. So you can just do however you need to sketch it. Otherwise, the last step is just choose any one of these x's and figure out how high that hump's going to go, or how your arrow is going to go at the ends. But in any case, for this college algebra class, as long as you get the main components down and sketch it, you'll be good. Since we did not have any repeats, remember the graph goes through the x's and not bounces off. Let's do another one. I want to do something that's bigger. Okay, so let's do a quadratic for a polynomial in the 4th degree. Okay, so we need to graph this polynomial function. Okay, so obviously we can't factor, so now we need to list our possible x's. So factor 24, plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, 8, 12, and 24. The reason why we have positive and negative is because any combination of these will give us positive 24. For instance, negative 6 and negative 4 will give us positive 24. Positive 4 and positive 6 will give us positive 24 as well. Our leading coefficient is 1, so this would be all over plus and minus 1, which you would still get this list. So let's go ahead and set this up. 1, negative 10, 35, negative 50, and 24. Now, this is the tedious part. This will take you a lot longer to do on some of these. And remember, you have a used column. If you use one of these numbers and it doesn't work, it won't work again later on. So that's why I always keep a used list over to the side. I'm going to just go ahead and start with 1. Okay, and I know this one works. So 1 goes into 1 one time. You get negative 9. So that's 26. This is 26. So that's negative 24. We get negative 24, which is 0. So we know that x equals 1. Now, since this was to the 4th power, this is to the 3rd. This is x third, x second, first, and none. So as you can see, if we wrote this out as a polynomial, we still cannot factor it. So what we're going to do, and since we're in still not in a quadratic, x to the 2nd, we can actually add on. We can keep doing this until we get down to a quadratic or a linear where x is to the 1st power, or even just a plain old number. So the next one, and I do want to tell you that if you use number 1, it could be used again. I'm going to go ahead and use number 2. I just know 2 will work. And anytime you do not get a 0 here, you need to choose another number. 2 times 1 is 2. And we get negative 7. Add, multiply, add. So we know 2 is a factor. Now, if you want to, you can keep going, or you can say, well, that's x squared minus 7x plus 12 equals 0. Solve for that. You can actually factor. If you can't factor it, you can use the quadratic equation, or a quadratic formula, excuse me. You can use the quadratic formula to find your missing values. So this has to be -3 and -4. So when you solve that, we get 3 and 4. So the values that will make y 0 is 1, 2, 3, and 4. Your left and right will go up. We have a positive value, so our right's going to go up. Even exponent, so our left's going to go up. And then our y-intercept is going to be all the way at 24. So put my graph here. We have 1, 2, 3, 4, and we have 24 way up here. Okay. I could go to 4, 6, 8, 10, 12, 14, 16, 18. No, I'd have to go 4, 8, 12, 16, 20, 24. There. We'll scale this 4, 8, 12, 16, 20, 24, 28. There we go. We can scale that and then keep this as ones. So our right's going to go up, our left's going to go up. This is our leftmost point. And then we have no repeats, so we'll go down here, up, down, up. So there's no repeats, so we are going to be nice and fluent through that, or fluid through that. Okay. Now, let's say we have a polynomial. Okay, haha, polynomial. And our x's are 1, 1, 2, and -2. Okay, and since there are 4 answers, this was a quadratic, or a polynomial to the 4th degree. And let's just say the y-intercept was 8. Okay. Now, to graph this. Now remember, if you have double x's, say we did all the synthetic division, we got all of our information, and we have 1, 2, and -2, and then we're at 1, 2, 3, 4, 5, 6, 7, 8. Okay. Our right's going to go up, our left's going to go up, and then remember on 1, we are going to bounce off. Hold on, let's make that -8, because I think that will be better. 1, 2, 3, 4, 5, 6, 7, 8. I think that would have to be -8. Yeah, it'd have to be negative, sorry. Okay, let's say it's -8, just so this can look better, because I don't know how I'm going to bounce off that 1 to go back down to try to get up here. And technically, I mean, if you have I'm not going to go into the detail. But anyway, left and right is going to go up, and then we're going to come here, bounce off the 1, come back down to 8, and come back up to the -2. You must bounce off of the 1 and not go through. Okay, so that's if your zeros repeat. I wanted to make sure that you guys know that, remember that from the last video. Okay, so one more. Oh, and this one, I'm not sure if it repeats or if we have, let's see here, imaginary values. Okay, if you have imaginary values, you just throw them out and just graph the real ones. So let's go possible x's. That's going to be plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6 all over, plus and minus 1, 2, and 4. So there's a lot of combinations here. You can list them out if you want to. I just leave it like this when I personally work, and I know that I have 1, 2, 3, and 6, and then I have 1/2 and 3/2 and 1/4 and 3/4 to work with. Because if you take 2 divided by 2, you get back that 1. 6 divided by 2, you get back the 3. So I can see all the combinations here. If you need to, you can write them out. I'm going to use a fraction that I know will work. Actually, it doesn't matter because I'll have to use the fraction later. Let's just start out with 1, since this is a 4th to the 4th degree. And I know 1 will work. I want to make sure that the numbers work, so this isn't a longer video than what it has to. But remember, if you do not get a 0, you need to try again. Now, we know x equals 1. I don't know if 1 repeats. Let's see here, 4, 7. Yeah, see that would give us a remainder. But I know -3/4 work. I'm going to show you how to do a fraction with this. So you can multiply by the numerator, divide by the denominator. So -3 times 4 is -12, divided by 4 is -3. And then this will be 0. That's 8. Or what I do is go 8 divided by 4 is 2. Multiply by -3, that gives us -6. Okay, so you could do that in 2 ways. I like to divide first and then multiply, or you could just multiply then divide. It doesn't matter, just as long as you're working something. So we know 3/4. So this will be x to the x/4, 4x squared plus 8, because we have 0 x's. So since this started out to be the x to the 4th, this level is x to the 3rd, and then this is x to the 2nd. And then we can solve for this. And x equals positive and negative square root -2, which is the same thing as positive and negative I square root 2. Well, I square root 2 cannot be graphed. So those are the other 2 answers. And I did not mention this before, but you should have 4 answers if you're degree 4. If you have a degree 3, you should have 3 answers. So the degree of your polynomial tells you the amount of values you have for your x's. So here's 1, 2, and then here's our 3, 4. We cannot graph those, so we're only interested in that. And then our y-intercept is -6. Oops, it's -6. Our left and right are both going to go up. We have positive, so the right's going to go up, even exponent, so our left's going to go up. So let's graph this. So we have 1 and -3/4, which is really close to 1, -1. Then we have -6 on the y, 1, 2, 3, 4, 5, 6. Our right's going to go up, our left's going to go up, and this, since our other values were imaginary, this is actually going to look like a quadratic graph. Okay? And that will conclude this video.